all, you have to be very clear that how you can compute the number of vibrations per second, and that is your frequency, time period, and how the amplitude of sound is related with the sound, right? So all these things you should be able to know up to now.
Sir, my final exams are in February. So
Okay, so we have completed all the chapters, and this
we'll
is the
start
last
the
chapter. Yeah,
we start the review today.
yeah, we are starting with the revision of sound, and then we will proceed to further chapters. Okay, starting with sound, we'll again go in the backward. We'll see what all chapters are pending for a revision. And if there is any chapter like bio or any other thing that you have not understood, so we'll take up that. Okay. Also, anything, just inform me if anyone is also getting the chapter, getting that chapter. That means the what we have, classification. Is there anyone who is getting classification also in their exams?
Is it deleted or not?
It's deleted.
Okay, then I don't have it.
But still, I'm asking, is there anyone if that person is getting that topic? So I don't think anyone is getting that topic, classification, right? So we start with sound. We will see what type of questions can be framed from this chapter. Up to now, we have studied this, and I want everyone to pay attention and see what type of questions can be framed from here. Okay. So till now, see the basically what questions or what formulas this chapter will be utilizing. So you need to be clarified here in this chapter about the oscillations and vibrations. So you need to be clear about, first of all, vibrations. And by vibrations, I mean you should be able to compute the time period, and time period is generally computed by the method of, if you know the time taken for n oscillations, so time period will be calculated by number of oscillations. So time divided by the number of oscillations. It is equal to the time divided over number of oscillations. So in this way, you can compute the time period. So vibrations will be given by the formula time period by the number of oscillations. In this way, you can find out the time period. Okay. So for example, you know the time taken for 10 oscillations. Okay. So time period will be given by time by the number of oscillations. Then the second thing, you should be able to compute the frequency of any wave or any oscillation. So frequency of oscillation will be computed as the formula 1 over time period, or you can write it something like this as number of oscillations divided by time. Number of oscillations divided by time will be called as the time period. So it's just the reciprocal of the time period. Then about the wave, this one is exactly the new one that you have got. Wave velocity. Wave velocity, it is computed by the formula lambda by t. Lambda by t, where lambda is the wavelength and t is the time period. This is also equal to f lambda, where f is the frequency and lambda is the wavelength. So how we got this f lambda? 1 minute. How we get this f lambda then? See, from the same expression, like here we have lambda by t. So we can write this as lambda into 1 over t. And as we know, 1 over time period is the frequency. Okay. So it can be written as lambda into frequency, the same formula. So wave velocity or v is equal to lambda by t, which is f lambda, where f stands for the frequency of the wave. And Orosmith, what is the unit of frequency?
Hertz.
Hertz. Very good. So the unit of frequency is hertz. Named after the scientist Hertz. So it's named after the scientist Hertz. So therefore the unit of the frequency is hertz. Okay. And wave velocity v will be given by f lambda. Understood this much? Then the second round of formulas that are related will be speed. So you get here speed of a wave, that is v. Speed can be computed by the formula distance by time also. So these are the two formula which can work. Distance by time. Either you can
Or
get it as distance by time or you can take it as frequency into wavelength. Depending on the question, what the question requires. So you will use the appropriate formula for that. Right? So maybe sometimes the question requires you to use frequency into lambda. So you use that frequency into lambda. Okay. So let's try to find out the small question depending on this. Now, always in the case of sound, whenever you are taking or finding out for echo, so for echo or for a reflected wave, whenever you are sending some sound and it is coming back, so for the echo, the distance we take as 2d. Okay, since it travels a distance equal to 2d, so whenever you are finding for the echo, you will take your distance to be equal to 2d. It's not d, which is it is equal to 2d, as the echo is produced by the reflection. So if suppose one way it travels a distance of d, the other way it travels a distance of 2d. Okay, so in this way the sound will travel a total distance of 2d. D distance from the source to the reflecting object, and again d distance back. So it will consider a total of 2d distance for to produce an E. Okay. Now the audible range of frequency that we have. So Siddharth, what is the audible range of frequency? Siddharth, what is the audible range of frequency? Yes, Siddharth, what is the audible range?
Sir, 20 hertz to 20,000 hertz.
Yeah, it is 20 hertz. You get it 20 hertz to 20,000 hertz. That is the audible range of frequency. So we cannot hear a frequency which is greater than 20,000 hertz, and we cannot hear a frequency which is less than 20,000 hertz. Okay, the frequency less than 20 hertz is called as infrasonic. The frequency greater than 20 hertz is called as ultrasonic.
sir, 1 kilohertz is like 2 hertz, right?
No, 1 kilo means 1,000.
So 1,000 hertz is 1 kilohertz.
Kilohertz. Yeah. and 20 kilohertz is 20,000 hertz. Okay.
So we can hear from 20 hertz to 20,000 hertz.
Yeah, we can hear these frequencies. Other frequencies we cannot hear. Now, measurement of the sound energy. How do we measure the sound energy? How do we measure the sound energy? See, sound
By
energy.
vibration.
No,
In
sound energy, it is measured in terms of decibels
hertz.
generally. The strength of the sound energy generally measured in terms of decibels, represented by the symbol dB. dB stands for decibels.
So what's the
However,
SI unit now?
SI unit of sound. Okay, anyone can tell the SI unit of sound energy?
Is it meters?
Yeah?
Meters. Is it meters?
Joule.
Oh,
It's
that's
energy. It's energy. So whether it be sound energy, light energy, any energy. So
Sir, you
SI
said it
unit of that.
now.
Yeah?
Decibel, right?
Yeah. SI unit will be decibels.
Okay, sir.
Measurement is also decibel.
Uh, yeah, measurement is decibel, but the SI unit is joule. SI unit if you want, so SI unit is joule since it's energy and all energy is measured in joule. Okay. Like heat energy, it can be measured in joule also and it can be measured in calories also.
Wait, sir, how do you measure in calorie?
In calorie. Okay. See, joule is generally considered as the work equivalent of that heat energy. Work equivalent of the heat energy. Okay, that is joule. And 1 calorie is 4.2 joule. 4.2 kilojoules. Okay, so these are the formulas. Let's try to solve out this question. I'm providing the question and I want the solution for from everyone. Siddhisri, will you be able to answer questions? Okay, so a tuning fork produces sound of frequency 50 hertz. Find the wavelength of sound. Okay, do this question. You are given the speed of sound wave as 340 meter per second. Okay, anyone got the answer? Siddhisri, did you get the answer?
No, sir.
Okay,
Sir,
which formula to be used?
sir, is it
Siddhis-
6.8?
6.8, what unit?
Meter.
Meter?
Sir, should it be in decibels?
So that what you are computing?
Wavelength.
Okay, and what is the SI unit of wavelength?
Hmm,
Wavelength is a type of length. Okay, so what will be the SI unit of length?
meters.
Meters.
Okay,
Okay,
sir.
so it will be meter. Anyone else who has computed?
So I got the same answer, 6.8
Yes,
meters.
6.8.
Okay, so the formula to be used over here is wave velocity V is equal to F lambda. Okay, wave velocity we know 340 should be equal to F, which is 50, multiply the wavelength, that's lambda. So by transposing, we get here lambda equals to 34 over 5, that is 6.8 meter. So the distance between two consecutive crests or the distance between two consecutive troughs will be 6.8 meters. Okay, understood this?
Yes, sir.
Now, the next topic I would like to discuss about is reverberations. Okay, so what are reverberations? I thought that most of you are having some vague idea of reverberation. Vague idea means you know what is reverberation, but you cannot put them in words.
Wait, sir, can you go back to the previous slide first?
Okay,
Sir, how did the 50 become 5 and the... Oh,
zero
okay,
and
you just... Yeah.
0 they cancel. You can just divide. You can divide both sides by 10, so you'll get 34 over 5. It's like this. From here, see, if you have not understood, you can very well look here. If you transpose, you get 340 divided over 50.
Yeah, it's the same thing, sir, I understand.
Yeah, so the same thing you can compute. If you divide numerator and denominator by 10, so you will have 34 over 5, right? And you can convert that 34 over 5 to decimal, which will be 6.8 meter. So what is reverberation? Let's see. It is the phenomena. Generally, we hear about reverberation whenever a number of reflections occur. So what is reverberation? It is a phenomena where that occurs. Let's see, it occurs when sound persists in our ears due to multiple reflections from roofs, roofs, and other objects. And decays slowly and decays slowly. So what happens during the persistence of vision? During the production of the reverberation. Suppose, see what will have when there will be a reverberation. Suppose you have a
It's like an echo.
see echo is something when you hear it distinctly. You hear distinct voices, but here you will not be able to get distinct voices. Okay, so that is a reverberation. You are hearing the same sound continuously. Okay? But echo is something different. If you see something like, let's say your room is also not that enough so that it can produce the echo, the echo cannot be produced, right? And suppose if you have the source from here, some sound is being produced. You have the production of sound from here. And suppose a person is sitting over, here and listening to this. If a person is sitting over here, a person sitting here, listening to whatever sound comes from here. So see what all sounds the person will hear. The person will hear a direct sound coming from the source. The person will hear a sound which goes to the surface and reflects back over here. The person will hear a sound, same person will hear a sound that goes to the opposite wall and reflects back to him. The same person will hear a sound wave which is falling on the ground and will reflect back to him, right? So you see here that the same person is hearing the same sound 4 to 5 times, right? And when he hears the same sound 4 to 5 times, what is the difference? That first of all he will hear this sound, then he will hear the second sound, then he will hear the third sound, then he will hear the fourth sound, right? So in this way he will be able to hear a number of sounds, and the difference between those sound waves, the time gap between them will not be the time gap between them will not be that much. It will not be so big that it will produce an echo. Okay, so what will happen? He hears some sound. Okay, and before that sound vanishes up from his ears, there is another sound of the same voice. There is another sound. So in this way the sound is persisting in his ears continuously. Okay, and he is able to hear that voice for a considerable duration of time, due to which he cannot differentiate between the sounds.
So it's similar to echo, but just a shorter like sound.
Yeah. Okay, so like suppose I'm speaking, I say muscles. Okay, so before I finish muscles, suppose I say muscle. If you once you will hear muscles, then after that you are hearing muscles sound that's coming continuously. So that effect is called as your reverberation. You can hear this effect of reverberation in an empty room. Okay, if the room size is small and the room is empty, and suppose if you give someone a mic to speak up, if you have ever faced this problem, that if someone is speaking through a mic in a closed room and you are listening to that person, you will observe that the voice is not audible. You are not able to differentiate between his different voices, right? So understood everyone? Any doubts in reverberation?
No, sir.
Okay, Harini, what is reverberation?
So the repeated echo is called as reverberation.
No, echo is different. Echo is different from reverberation. In echo, what happens? You hear a sound clearly. Suppose I say any name. Okay, I say Ram, and that Ram is produced. So after some time, again I hear the complete sound Ram. Okay, so that sound is called as an echo. But the reverberation is different. What happens in the case of reverberation? In the case of reverberation, you do not hear the complete sound. Only a part of the sound will be produced and heard. So, till you hear that the sound is still coming in your ears, the speaker produces the second one, and that also reaches your ears. So, in this way, you will not be able to differentiate between those sounds. Okay, so I think if I can find any sound of that, so I can play. If just just one, if you give me 1 minute, let's try to find out if there is any reverberating sound which is available, so that we can hear to it and we'll be able to differentiate clearly between echo and reverberation. Okay, just 1 minute. I think it should be available. I actually want the sound. Okay, I don't think that it's available. Okay, no, it's not available. You can, however, search for it and see if it's available. You can go search it. If you get, then that's well good. Okay, or in a room only, if you try to speak with some speakers, so or with a mic, you will be able to hear reverberations. Okay, so I don't think that there is any other doubt in this chapter. We shall solve the all the questions or assignments if there are any from this chapter now. In the last class, we were solving one of the assignments. Uh, Okay, let's see some of the assignments. Mhm. Just 1 minute, huh? Okay, let's see. Okay, so I think now the screen is visible to everyone. Can everyone see the screen clearly now?
Yes.
Yes, sir.
Okay, so it should be readable. Okay, so I think it's readable now. See this numericals. Frequency of a source of sound is 500 hertz. How many times does it vibrate in a minute? So let's see. You are given frequency of the sound wave is given. Okay. So who can solve this? Frequency of a source of sound is 500 hertz. How many times does it vibrate in a minute? You have to find out the number of vibration in a minute.
Sir,
Okay.
if it's a decimal number, do we round it off to the whole number or give the 2 digits?
Decimal numbers are to be rounded off. Correct up to 2 decimal places. Okay. So now Siddhisri. Siddhisri.
Yes, sir.
Okay. So I am not asking you to solve the question, but whatever I am asking, if you are able to answer, just answer this here. Can you tell me what is the number of oscillation, number of vibrations per second? What is the number of vibrations per second here in this question?
Sir, actually, I was not there when did you start the lesson.
So Siddhisri, which question can you answer then? Keep an eye and attend your classes regularly. Oro Smith, can you tell from the question what is the number of vibrations per second?
Yes,
Okay, so what is the number of vibrations per second?
500.
500. Very good. So number of vibrations per second is 500 hertz, right? Now, Rishika will tell. Rishika, so how many number of vibrations in 60 seconds?
Sir, I got a decimal number. I rounded it off. I got 9.
No, see, what I'm asking from here,
Yes,
just
sir.
answer me. What is the number of vibrations in 60 seconds?
1 second.
How many?
Sir, I got 8.3. I divided them both. 500 by 60.
No, just see what is written here. I have written here number of vibrations per second. Understand the meaning? The number of vibration in 1 second, you can also call it. Yes, this is the number of vibration in 1 second.
So 30,000 hertz.
30,000.
Yes, sir.
See, number of vibrations in 1 second is 500 and number of vibrations in 60 seconds. So what will be that?
So 30,000 hertz, right?
30,000. 500, not hertz. That will be just vibrations. So you have 500 multiply 60.
Yes, sir.
Sir, 3000.
Yeah, 30,000. So
30,000.
30,000 you get. Okay. Multiply, you get 60. That's 30,000. You get this answer 30,000 vibrations. Okay, so did you understand the question? Question did not involve much complicated things. It involves a simple understanding. So Rishika, did you get the answer?
Yes,
Sir, but the question didn't tell us that was the number of vibrations in a second.
So it is the frequency. And what do we mean by the frequency?
Okay, in a second, this much is being produced.
Yes, frequency means the number of vibrations per second. Okay, so uh, never mind, even if you got it incorrect, try to correct the next question. Okay, let's see the next one. So your next question, see, I think this should be answered by everyone. A ship sends out signals So this is another question. Let's do this one now. Okay. So try to solve this. A ship sends out sends the a ship sends out ultrasound that returns from the seabed and is detected after 4 seconds. If the speed of ultrasound through seawater is 1550 meters per second, find the distance of the seabed from the ship. So Rishika, which formula is to be utilized here?
Here, distance by time. Speed equals distance by time.
Which formula?
Here, speed equals distance by time.
Speed equals distance by time. Okay. So, okay, use it and tell.
Sir, no, I used the distance equals speed into time.
Okay, that's same. Distance equals speed into time. Both are same.
Oh, okay, that's right.
Sir, I got the answer.
Okay, what is the answer?
Sir, 6,200 meters.
Sir, I got the
Here, I
answer.
got
So like
something different.
I got 3,100 meters away from the ship.
Sir, 6,200 meters away from
Okay,
Sir,
the
sir.
6,200 meter.
Okay,
Sir, I
see.
got
So,
Here, I got
3,100.
3,100.
see, the distance is something like this. It goes and returns back.
Sir, we have to consider the actual time as 4 seconds by 2, so its actual time is 2 seconds.
Yeah.
So it's 3,100.
Okay. So either you use the formula that 2D will be equal to speed into time, 1550 into 4. So your D will be equal to 1550 into 4 over 2.
3,100.
100.
So you get 3100 meter. So the seabed is 3100 meter. Right?
Yes.
So that's the distance, 3100 meter. Then either you do it this way or you can think like this, that it takes 4 seconds for the sound wave to go and come back. So just to go, it will take to travel the distance d, it will take the time 2 seconds only. You can either half the time or you can use the formula 2d. Okay. So I think there was only one person who got something as 6,200, and that was the mistake that he did not took is at 2d. Okay. So understood?
Yes, sir.
So let's see the next one. And I did one such question in the last class, but now I would like you people to do this question. Okay. So one such example I had done. Okay. So I'll just explain this to you and I expect the answers. Is there anyone who can solve this without any explanation? You can see the question.
Can
I
we
have the
try?
question.
So, can we try it
Sir, I
first?
think I can do it.
We try.
Yeah, those who know, they can try it out. A person standing near the cliff fires the gun and heard the echo after 1.5 seconds. If the sound in air is 340 meter per second, how far each person from the cliff? So it's direct and echo question. Use the echo formula. Use the echo formula and obtain the distance. Okay, got the
Sir, it's
answers?
the same thing as the last question.
Yeah, the same thing. You have to do 2D will be equal to speed into time. That's 340 into 1.5. And D will be equal to half of this. So that's 170 into 1.5. Or you can make it 3 by 2. So multiply and divide. Did you get the answer?
Sir, 255 meters.
255 meter. So speed of the sound in air is the distance of the cliff is 255 meter. Who all got this one correct? Siddhisri?
Yes, sir. I got, sir.
Okay. And Oro Smith, Harni Siddhisri, did you get the answer?
Yes, sir.
Uh, okay. So try doing the other one. Let's see the next one. A sound wave. This one. So this I'll not be solving. I'll just tell the answer after 3 minutes. I will tell the answer. Before that, if you know the answer, if you got the answer, so tell that answer. See, everything is given. I won't tell anything. I got one answer from Chavan. Let's see the other answers.
Sir, I sent my answer.
Yeah.
Sir, I sent my answer.
Okay, let's see. Okay, I got Harini's answer. I got Oro Smith answer. please write your units also. Okay. Okay, I got four answers. I've got four. Still, I'm waiting for three more answers to come. I'm waiting for Siddhisri and Siddharth. Okay, Rishika has given the answer. Siddhisri and Siddharth, they are remaining. Okay, so let's continue now. Siddhisri, which formula to be used here? Can you guess the formula that will be used?
Sir, I'm not getting this one.
Okay, so write this in terms of symbols. From the first statement, what you get, what is given in the first statement? Siddhisri, what's given in the first statement? Siddhisri?
Yes, sir.
Yeah, what can you know from the first statement? What value is given? A sound wave travels with a speed of 339 meter per second. So what do I get from here? Can I write from here that the speed of the sound wave or speed is equal to 339 meter per second?
So speed is equals to 339.
So that is what I am asking. It's given from the first question. In the second part here, if its wavelength is 1.5 centimeter. So wavelength over here is 1.5 centimeter. And what is the symbol for wavelength? Which symbol do we use for wavelength? Yeah, see this, which symbol do we use for wavelength?
Sir, can I?
Yes,
Sir, lambda.
lambda. So we know here lambda will be equal to 1.5 centimeter. So I need to convert it to meter. 1.5 centimeter will be converted to meter.
Sir, it will be 0.015.
Okay, divided by 100 will make it, let's make it 1.5 over 100 meter. So this is your wavelength. You can write it as 0.015 meter. Okay. So how do we calculate the frequency? So which formula
Frequency
will be
is
used?
speed by wavelength.
Okay, so speed by wavelength will be equal to frequency. We can use the formula speed equals to f lambda. Okay, so use this formula. You have 339. So 339 divided by 0.015 will be equal to frequency. Removing all the decimals from the denominator, you get here 10 to the power 3. Divide the rest. Let this 10 to the power 3 be kilo. And divide this.
It will become 22.6 kilohertz.
22.6 kilohertz. This is the frequency. Or you can get it if you write it without kilo, it will be 22600 hertz. Either you write 22.6 kilohertz or 22600. So let's see then. Hello. Hello. Oh, class. Okay, so I think almost everyone had got it correct. Just I think one or two people were not able to obtain the answer. So let's see, and we will see the other questions in the next class. Or if possible, I think I shall send it in the PDF so that you find it and do these questions. Okay.
Yes, sir. Can you send it in the WhatsApp group? I have to finish them.
Okay. So bye everyone. Good night.
Thank you, sir.
See
Bye,
you
sir.
all in the next class. Okay, bye. In the PDF, you'll find the remaining questions. I'm just attaching right now. Okay.